Hello everyone, welcome back to my YouTube channel. I have started a playlist of data science covering the basic and advanced concept. Now my next topic is model evaluation. Now let's discuss what is model evaluation. Model evaluation in data science refers to the process of assessing the performance of machine learning or statistical model on a given dataset. The goal is to determine how well the model generalizes to unseen data and whether it accurately solves the problem at hand. Model evaluation is a crucial step in building machine learning models where you assess how well your model performs on unseen data. Now, let's discuss what are the common types of models. First is classification model, predicting categorical outcomes. Second is regression models, predicting continuous numerical outcomes. Now, let's discuss how to select a model. Once a model is evaluated, you compare the performance of different models using the evaluation matrices to decide which one is best suited for the task. Consider accuracy for balanced dataset in classification. Second, precision and recall in unbalanced datasets where one class is more important than the other. Third is MAE or MSE for regression task based on how large prediction errors are treated. So this is a diagram which tells us what are the parameters to select model. Now, steps for model evaluation in Python. First, import libraries. First, you will need to import the necessary Python libraries. You will typically need NumPy for numerical operations, Pandas for data manipulation, scikit-learn for machine learning and evaluation matrices. Second, prepare the data. Load your dataset and split it into features and labels. Then divide it into training sets and test it. Third is train the model. Next, train a model using your training data. For example, we can use random forest classifier for classification task and linear regression model for regression task. Last, make predictions. After training the model, use it to make predictions on the test data. And at last, evaluate the model. You can now evaluate the model using various matrices, for example, accuracy, precision, recall, set score, etc. Now let's discuss what is unequal errors caused in data science. In data science, unequal error cost arise when the consequences of different types of prediction errors are not equally important. Accounting for unequal error cost involves adjusting the way we evaluate an optimized model to minimize the errors that have higher cost. This can be done by modifying the loss function, decision thresholds, or using appropriate matrices. Now, what are the steps for accounting unequal error cost in Python? First, define the cost for different errors. Define a cost matrix that quantifies the cost associated with each type of error. For binary classification, the cost matrix is typically a 2 by 2 matrix where each cell represents the cost of particular combination of predicted and actual classes. Second, implementing the cost matrix in Python. Let's assume you are working with classification models such as logistic regression model and you want to account for the different costs associated with the false positives and false negatives. Third is adjusting the decision threshold. In standard classification, the decision threshold is typically set to 0.5. However, you can adjust the threshold based on the error cost to minimize the more expensive errors. Next step is custom loss function with cost matrix. Another approach is to define a custom loss function that directly accounts for the unequal error cost. You can create a custom objective function that penalizes the model according to the predefined cost matrix. Last, optimization with cost-sensitive learning. In some cases, you may want to use cost-sensitive learning where the model directly learns to minimize the cost of errors instead of simply maximizing accuracy. Some algorithms like cost-sensitive SVM or ensemble methods allow you to specify class weights or cost matrices during training. Now let's move to the coding part. Here I have given a code to perform model evaluation using Python for both classification and regression tasks. First, discuss for the classification task. Import pandas package with the alias name PD and import necessary libraries such as train test split, random forest classifier, accuracy score, precision score, recall score, F1 score, confusion matrix. Now load the dataset. In order to read data in the form of CSV format, we have use pd.read CSV. And in order to replace target column with the name of your target variable, I have used draw function and then specifying the target variable. In order to split into training data sets and test sets, I have used 4 parameters: xtrain, xtest, ytrain, ytest, and using split function to perform splitting. Then I have used random forest classifier To train random forest classifier, I have used a random forest classifier function. In order to make predictions, I have used model to predict function. In order to evaluate the performance of model, I have used various parameters like accuracy, precision, recall, F1, CM. At last, I am printing the results. Now, in this session, I am providing the code for regression task. You can see the code by this video. Now let's see how to perform accounting for unequal error cost using Python. First, import numpy with alias name as np, then import pandas with alias name as pd, then import necessary libraries like trend, taste, split, logistic regression, confusion matrix, accuracy score, etc. Then I have provided sample data in form of dictionary. In order to read data in the form of data frame, use pd.dataframe format in which we are passing data as a parameter. And then in order to split data into features and target, I have used drop function. In order to split training and test sets, I have used 4 parameters and split function. In order to use the train logistic regression model, I have used logistic regression. And then in order to predict probabilities, I have used predict probab function. And then I am defining the cost matrix by using cost matrix variable. In order to adjust decision threshold, first we need to specify or assign some threshold value, and then we can also adjust threshold value according to our needs. And then we will calculate the confusion matrix by using confusion matrix function in which we are passing y test and y pred adjusted parameters and storing the result in cm variable. And in order to assign confusion matrix into variables, I'm using revel function, and then we are calculating total cost. At last, we are evaluating the model performance by using accuracy score function and storing result in accuracy. We can also use another parameters like precision, recall, F1 score, and then can store the result in other variables. At last, I want to conclude. Thank you for listening me patiently and happily.